Hi everyone, welcome to this video on modeling an economics problem using E and natural logarithms. So what we have in front of us is a table showing the time in years and the gross national product of a particular country. You can see here that the gross national product increases as the number of years goes by, and what we want to do is to try and get a model of this in terms of an exponential function. So what we're really going to try and do is produce some kind of model which says that the gross national product is equal to some function, a b there, some constant which we'll need to work out, multiplied by E, and then a second constant up here, a, and the whole thing will be modelled as a continuous function of time. So we have t for time at the end there. That's what we want to be able to do. Extract from the data values for b and a given t and the gross national product you can see in the chart. Okay, so things to notice: it's definitely exponential. Between years 1 and 3 it increases by 5 units. Between 3 and 5, again 2 years, it increases by 7 units. And that pattern continues. The GNP grows exponentially as time passes. So let's just take a look at what that might look like. Well, here I have already managed to produce in Desmos a graph of the thing. It's always a good idea to draw a chart, see what you're working with. And here you can see the same data now plotted in Desmos. I'm just going to lock that down there. And here I've plotted it on a domain there between 1 and 20, which is all the data we've got. Anything beyond this point, we would be extrapolating. We'd be taking data outside the range of numbers that we've got. So you can see then that the chart does follow a curving pattern as it goes upward. It's an exponential function. We could try and estimate figures here, 20 up there. We could try and estimate the slope to try and get some information about what any one figure here might be for a different value of t and so on. But what we're going to do is to produce a linear model of that. And for a linear model, you remember that previously we had to use logarithms. Now, the logarithms are going to be applied to this bit here. We're going to try and extract b and t, but in order to do that, we're going to take logarithms of both sides of the equation, as we've done in the past. But we're not going to use log 10, because we are working with a different function here. We're working with e. We're not going to use logs to the base 10. We're going to use logs to the base e. And on your calculator, these are usually written out as ln. You should be able to find that easily enough. So I'm going to take logarithms of both sides. So I'm going to go log n of the GNP on one side, whatever that happens to be. It's going to be equal to, well, remember that if you take the logarithm number, we're looking for what is up here. What is the power function piece up here? So we're going to have a t, that's the logarithm of v, and then we're going to add to that whatever the logarithm of the b function is. And you can see that straight away that this is in the form y equals mx plus c. We have a linear function now. So what we need to do is to plot that on a graph and come up with some answers. Okay, so let's just not worry about the chart. The chart is going to have its own particular form, but let's just see if we can calculate some of the values. Let's try and calculate m and c without resorting to a chart. For that, we're going to need a bit more data. We're going to need the logarithms, so I'm just going to bring those in down at the bottom here. Let's just move our chart up. So here are the data again, and this time on the end I've added a column with the logarithm of the GNP. Let's just take a particular set of years. Let's just go from year 5 and year 1. And we'll compare those 2 years, what's actually happening. Okay, so year 5, and we're going to subtract from that year 1. So we're looking at that data there and that data there. We're going to see how much the logarithm increases between those 2 dates. So we have the change in the x value is 5 years and 1 year. The change in the other value on the top, if we find the slope, is 3.55, which is the value there, minus 3.11, which gives us, when we work that out, 0.44 divided by 5 minus 1, 4, so that the value for this slope is equal to 0.11. So that's the slope. So that is the value of a in our little function. So we've calculated already the value of a. How do we find the value of b? I've actually drawn that incorrectly. That should be log n, of course. I'm sure you all noticed and were sending me notes. Okay, so that's the log n of b. Well, we can work some of these out. We can take any of our particular values and use them to find out what the b value must have been. So, for example, here we know that when we have 1 year, the log n of the GNP is 3.11. So we know what the y is, we know what the slope is, we know what the x is, and the only unknown bit is going to be this bit here. So, in order to find the value of the b, we take the y value, 3.11. We take the a value, 0.11. We take the year's value, which in this case is 1. And we know that if we add on the log n of b, we'll be able to get an answer out. So what we've got here is 3.11 is equal to 0.11 times 1 plus log n of b. Okay, so we're going to say 3.11 minus 0.11 is equal to the log n of b. All I've done is subtract that part from that part. So our log n of b is equal to 3. And now if you want to find the actual value of b, we have to take the log n of b and raise it to the power of e, or e raised to the power of that will give us the value that we want. So what we want is the value is e to the 3. Okay, right, that's the log n of b is equal to 3. Therefore, the value of b is equal to e to the 3. That's what the log actually means. So we go to our calculator and we type that number in, that b is equal to e to the 3. And when we take our calculator and put that number into the thing, we have e to the power of 3, which gives us what number out? 20.08. 20.09. So there we go. We've just used the basic ideas behind linear algebra to produce our model. Let's just write it out clearly. What we intended to do was to come up with a model GNP equals b e to the at, there in orange at the top. So to finish off that point, we can now write that the GNP in terms of our model is equal to 20.09 times e to the 0.11 t. That is our model based on the data that we were given in the first place. And then we can use that model then to predict one point that we didn't have. So let's just say we had t equals 13, and the GNP in 13, if the model is correct, is 20.09 e to the 0.11 t GNP equals 20.09 e to the 0.11 times 13, and if we run that number into our calculator, what comes out is, well, let's have a look, shall we? And the calculator tells us then that the GNP, if the whiteboard would just sit still, it is a figure like that, 83.95 billions. There you go. I hope you found that video useful. Thank you very much. I'll see you again soon.